Welcome back, algebrists. Today, genuinely, the lesson is going to be pretty chill. No cap, my guys. So, let's start slapping. I don't know. That doesn't work, I don't think, but we'll pretend it did. So, here we are. Here's your assignment. That's going to be way too loud. Here's your assignment from yesterday. We needed to factor everything. Now, that's what my direction said. Just do this. That's my first annotation. Okay, if you are struggling with factoring, when should you come see me to get help to clear up factoring? Love it. After school, during lunch, before school, you can email me. There's a bunch of old videos. There's a million ways to do it. But if you're struggling with it, class is not going to get easier if you're not good at factoring. So keep that in mind. Looking at this, I'm just going to check little bits and pieces. In the numerator, what's the first thing you did with factoring? We check for GCF. Is there one? Now, when I take out an x, it leaves behind x squared minus 4, which in my head or on page, if I write it, I recognize the difference of two squares. So right off the bat, when I factor this, I think an x comes out. And again, if you need help getting to this point with the factoring, please let me know. Let's work it out. But that, I believe, is what the numerator turns into. Okay, the denominator, I cannot factor in my head. I should take the time to learn how to do it in my head. I just never bothered. How do we factor this one? So here I am. How do I even start thinking about factoring? 6 and 5 is 6 and negative 5 is a better way to say this. Negative 30. Factors of negative 30 that add up to negative 13. 10 and 3 is the first natural thought, but one of them has to be negative, so it's either 7 or negative 7. That one won't cut it. But 15, positive 15, and I'm going to start making this more of a habit, and negative 2. Ooh, other way around. Good catch. Was it on purpose? But yes, it was. All right. What do I do with these? Make it a 4-nomial. I'm okay. I know what you're saying. Okay. I'm not going to finish the grouping, but we're going to check. What did you guys get for the factorization of the denominator? 2x minus 5 and what? 3x plus 1. Awesome. Now, if you got in here and you're able to do this just completely on your own, that's awesome. Like the factoring, I legitimately think is the hard part. Yesterday, the other piece, and I don't care how I write it, we're going to factor this one also. It has to be. When I write it here, do you want me to make it a fraction over 1 or just keep it like it is? Over 1 is going to make it easier to see what we're doing. I don't really mind if you do it or don't do it. Easy. But let's check it out. How does this guy factor? Common factor first. X. And then I believe, and check me if I'm wrong with this, but I think it's an x plus 1 and a 2x minus 5. Okay. And that's all over what? 1. Now, at this point, there are a few different routes that one can take when thinking about these. If you want to, we could write it as a single fraction. And I'm going to just do that here off to the side in a different color because in reality, I don't know that it really matters. Weird, I could not find my colors, but there they are. So check it out. If we do this, I would probably not do another line of work, but is this the same thing, and this is an optional line, as writing it like this? X minus 2, x plus 2 times x, because I'm just going to multiply straight through. And I'm going to put the x out here so it feels a little bit more natural. X plus 1 and 2x minus 5. Is that the same thing that my numerator would be if I actually multiplied them out? If you want to write this, you can. It's not a requirement, but you can. It looks like it's just going to be the same things. 2x minus 5 and 3x plus 1. Now, whether or not you elect to do this, again, I just want to stress, entirely up to you. Because if you can see what's going to divide out on this step, there's no point in writing this one. If you can't see what's going to cancel out or divide out here, then we should probably write this one. Now, first question that I have for you, and this is going to be a strange one, and I want in your group, I'm going to give you like 15 seconds. How many factors do you see in the numerator and how many factors in the denominator? I want you to count up top and down below. How many factors are there? We'll go like 15 seconds. Chat with your neighbor real quick. 6 up top, and how many down below? I think there will be 5 up top. Yeah. Good. Okay. Check it out. There's a couple answers, and this is try not to be ambiguous as often as I can. How many up top? I think I'll accept 5 or 6. Why? If I wanted to call this x squared instead, I could. And that's one factor if I write it like that. Right now, it's a true factored form. X times x works just as well. I see 1, 2, 3, 4, 5, 6 of them because my parentheses where they'd be. Downstairs, how many? 2. Now, does anybody in here feel like you are going to take the time to go from this step to this step? Okay, to go from, and I'll add this annotation. First, we factored everything. And then on this line, we combined to one fraction. And this is the optional one. How many of you guys would combine these to one fraction? Okay, and that's totally okay. I'm going to show this works in both of them real quick. In this one, if I can identify everything in the numerator, all 6 of those factors that you guys just told me, and I can identify 2 of them down here, all I'm looking for is, in this line, is there a factor that's common in both the top and the bottom? So there's a 2x minus 5 down here, and there's a 2x minus 5 here. They would divide out in this line if this is where we stop. Any other common factors? That's it. Now, in this one, it's the same thing, but it might be a little easier to see. Common factor between the bottom and top. It's that same 2x minus 5. So whether we go with the black version of this, where I don't combine them, or the red version, notice what's left. X minus 2, x plus 2, x plus 1. X minus 2, x plus 2, it's the exact same answer. I'm going to let you guys make the decision there, which means if all we're trying to do is multiply these and give our simplest expression, how do I write the top in the nicest possible way? So I'll tell you one thing I know for sure is I'm not going to write 2x. X squared seems reasonable. If you kept it as x times x, will I count you wrong, you think? Not a chance. So x squared, give me another factor. X minus 2 and x plus 2 and x plus 1. Fantastic. Denominator? 3x plus 1. And we're done. Now, I'm going to try to do this more consistently than I always do. The parentheses, whether I write them or not, remember, they are there. Cool. Now, I am going to add one more follow-up expression to this. If we have all of this work showing, and we do right now, last little question, and I'm just going to write it as here, and you don't have to take up a crazy amount of space because it's only going to be a little tiny bit of writing. If this product that we just did, this ugly thing times this, was called a function, like f of x, find me the domain of that function that we started with. And just so you can see, so it's super clear, I'll make this bright green or dark green, I don't know. If we had called this f of x from the beginning, how do I find, or rather, what is the domain of f of x? I'm going to give you guys the same thing on a pause the video here. I want like 60 seconds. I'll flip the red timer. Talk it out with your neighbors. Help me find the domain of this. Cool. Off the bat. When we're thinking domain stuff, anybody here struggle with domain stuff from time to time? Naturally. First thing I care about, and we're just going to make a couple comments. Again, I'll use pink so it stands out. What does pink mean when I write it in pink up here? Hot pink for hot think, right? That's what we decided was the cool phrase. That's what the cool kids are saying in the hallways I hear. Anyway, check it out. When we're talking domain, just a couple things. What are we actually talking about? The x what? It's not the intercepts. The x values, I'm just going to put a couple asterisks. The x values that we can do what with? So that touch. And this is like pretty specific, but I'm going to make a claim here, and I just want to see if, yes, I understand and I agree, or I can read it, but I don't really know what it means. I'm going to say it's the x values that my function is defined for. Okay, this is a pretty formal way to say this. We're going to have a layperson language here in a second. The x values that my function is defined for. This is one way to think about it. Real quickly, just with thumbs up or down. Yes, I'm cool with what this means, or thumbs down, like what? Down. No. Okay, you got me good. Okay, so is there another way that we've talked about domains then?
Axis.
Say that again. So it's definitely the x values for sure. Now, when I say it's that my function is defined for, there's another way to word this. And the more common language that I use just in conversational stuff is what breaks my function. And when we ask that question, our list is going to start getting longer and longer. We are working with the real numbers. Unless we're specified that we get imaginary stuff or complexes, we're probably not going to use i's and things. Just keep that in mind. So I'm in the real numbers. If I want to have a real number defined, there's only two things I believe that you guys know of that we can't do. I can't take the square root of a negative because that makes me leave the real numbers. Do I have to worry about any square roots of negatives here? Why not? You're right. No. I saw several people say no right away. How come I'm not concerned about taking the square root of a negative number for this problem? So, because the imaginary part, but not quite what I'm looking for. How come I'm not wondering what x's make me take square roots of negatives for this problem? That's one of the two ways that we break functions, square root of a negative. Why don't I worry about that here? So I'm going to ask that question. You're going to feel silly, I think. How many square roots are there in this?
1, 3.
So careful. You see a square root? Or do you see a square? Are there any square roots? So I'm never going to take a square root in this problem. I don't have to worry about it. So not going to happen there. Where's the other place that my function can break? When I try to divide by something. 0. What's up, Lando?
I was going to say 0.
0? Awesome. I can't divide by 0. Now, we started with this and we started factoring. We, on this line, have our equivalent expression. And then we have this simplified expression down here where we cross something out, right? What values of x from this version would have broken this function by dividing by 0? So let's see, what factor divided out? So I'm just going to do a little scratch work here. I know that if 2x minus 5 were 0, it breaks it, right? Okay, if that were 0, what x would it be? Help me solve this for x. Add 5, good. And divide by 2? Sorry. So I think it's 5 halves. So if I had picked x equals 5 halves from the get-go, it would have made me divide by what? 0. And can I divide by 0? So I'm going to make a note. We can't use that. Can't do it. Is there any other value? And I only did this one here because it's where we divided it out. Down here, is there any other value that makes me divide by 0? So it's the 3x plus 1. And I got two answers, but they're both correct. It's when 3x plus 1 is equal to what? Now, here's a little weird thing that I don't know the right way to do it or just write it down. We're really finding the values that x can't be, right? And it feels weird in my head to say, here's an equation of what it equals, and then I just switch it to doesn't equal. If you want to do it this way, I'm open to it. Instead of saying, when is this equal to 0, is that the same thing as me wondering what x values can't this be? Is that the same question? When is 3x plus 1 equal to 0 is like me saying, when does it make me divide by 0? And now I'm just saying it in one step. What values of x can this not be? Do you guys see the difference between those two or no? It seems weird to me to solve a not equation is what's weird about it, but notationally it makes sense. Okay, we're going to pretend like, check this out. Strike it from the record. The jury will disregard. Okay. Little law joke. Okay. What x value makes the denominator 0? So subtract 1, divide by 3, and I get negative 1/3. And this is that weird part. We can or cannot let x be this. Cannot. So there's that same idea. Now, I've just identified two of them in here. Are there any other x values that make me divide by 0? So I'm getting some blank looks with that one. Let's dig into that. I need to make sure I don't divide by 0. Are we all cool with that? I found that at this part of the problem, even though it divided out, it would have made me from the original, right? So I say we can't pick this. And then at the end, when we have our simplified version, we say, oh, this is another value of x that we cannot pick because it would make me divide by 0. Have I covered all possible x values that make the bottom 0? Yes. Yeah, because I've covered both of them right here, right? Are there any other values of x that would make me divide by 0 other than those two? So every other x value out there works, I think. Because there's no weird negative square roots or anything like that. These are the only two x values that don't work. Agreed? So how do I write that? The domain is all the x's except those. Is there a convenient way to write it? What do you think? Are you going to give me interval or set builder?
It's the ones with like the vertical lines you put on. And
Love it.
Like double X.
The set of x, and I'm going to make that a nicer bracket because that one's awful. The set of x such that, this is set builder, Sonny, just so you know. X can be any number except what? It can't be negative 1/3, and it can't be 5/2. Now, for these, same thing. If you need the annotations, if you want them, I'm just going to put one more here. These make denominator 0. And that's how we decided those. Only 2 ways that we have right now that we break functions. I guess, did we do logs in here? Have we done logarithms? Okay. Yeah, for sure. What is the other way? Interval notation works here as well. It's kind of uglier. Now, I wrote these numerically, sequentially, right? Negative 1/3 is left, and then 5/2 is next on the number line. So how far to the left can we start? Negative. So we start, and I'm going to make this more formal. We're going to say it's x in the interval. And let's say we start at negative infinity, and we start working to the right, and we're good until we get to which x value? So negative 1/3. Can I touch it? Because it makes me divide by 0. Not allowed. How do I marry this with the next step? You need to do something first. Union. And now, Angel, go ahead. Negative 1/3 to where? Love it. Can I touch 5/2? No, it ain't allowed. Union. One more. 5/2. All and beyond. Cool. For either of these, they both work. I'm okay with both of them equally. I'm going to be honest. I think this one's much easier. And by easier, I mean less writing. Cool. All right. These ones feel okay, feel terrible. Okay. Should we do one more like this? Or do you want to do a hard problem together? Okay, one more like this. I'm going to give us a pretty chill one. I'm going to throw you guys a curveball here. And it's not going to be crazy. And I wish I had my 89 handy, because that's what I use to make nice things at Factor conveniently. But let's check it out. We can find a nice one here, probably. We only have one more section in this chapter, guys. Isn't that exciting? Yeah, I can tell you're excited. All right. So, bear with me for like 2 seconds just so I don't get an ugly one. What's the opposite of exaggerate? I wish under would be something that should work in my head. Under something, but it doesn't work. All right, here we go. You guys need to work together. I want us to solve, or simplify rather, x to the 4th plus x cubed minus 30x squared. And we're going to divide that by x squared minus 3x minus 18. All right. You ready for this crazy 12-6 curve? Okay. Divide it by x cubed plus x squared minus 30x. X cubed, sorry, I'm losing x cubed plus x squared minus 30x. Are we going to divide that bad boy by x squared minus 36? Okay, if I asked how much cash do you have, there's a particular answer in my head that's related to TikTok or Instagram or something. I don't even know where it comes from. It's not 6 or 7. I got hella cash. There's a reason that I'm recognizing that in my head. I don't know if you guys are making the connection. Do you remember why we were doing hella the other day? I prefer the holla whoa, personally. There's a reason that I'm mentioning hella, because they do this in it, right? Something I don't know the dance. Anyway, have fun with factoring. Talk it out. I'm coming around to help if need be. Cool. Factor. Before you, factor everything, I'm cool with that if that's the first thing you do. But if you'd like to check before you try to finish this problem, I'm okay with it. There are a few different approaches that you can go with this. And it's really cool that there's a few different approaches. Okay. Ouch. Okay, so looking at this, couple different things. We have two choices to make right off the bat. Do we start by factoring or do we start by multiplying by the reciprocal? Because when we divide, if you don't know the hella reference that I'm trying to make, please tell me if you have no idea what the reference is. I'm too cool for many of you. Okay. No? Okay, all right. This is really how I think about it. Why would I want this in your head? If you divide by a fraction, like a fraction here and a fraction here, keep, change, flip is your guys' language. I don't like that. I don't hate it. I just never learned it that way. I multiply by the what? So whether it's this, and we're feeling a little like rock and metally, or you want to do the whoa a little bit. Hold on. Okay, or something about hella, and I don't really know it. I've never seen it, but somebody referenced it the other day is the only reason I'm saying it. Multiply by the reciprocal. It's the big idea that I'm after. Do you want to factor everything first, or do you want to rewrite this as I'm multiplying by the reciprocal? Okay. We're going to see, I am going to show it the other way, just in case somebody had said that. This leaves behind what? Okay, I love this trinomial. Why? The leading coefficient is 1. Now, for the bottom, can I just factor it already? Why? Oh my gosh, can you guys give me factors of negative 18 that add up to negative 3? Plus 3 and negative 6. So, x plus 3, x minus 6. Okay, for the next piece, am I just going to write it as divide still and just do the same thing? Or do you want to flip it now? Because it doesn't really matter when we do it as long as we do it. Could I flip it here if I want? Okay, so dividing changes to multiplying, and I'm going to write it out here. And I know that some of you guys can factor this like right through here. I'm going to leave this one for a second. What factors out of this one that's now going to be in the denominator? An x. And we'll catch up here in just a second. Now, for this, for those of you that said factor first, I have no issue with it. Like, I'm totally good with it. If we hold off on just a second without factoring every single piece, maybe there's a benefit. So what I'm going to do here is I'm just going to make sure it's very clear. Divide by fraction, and I'm going to say divide by a over b implies multiply by b over a. Like, that's my reciprocal idea. Now, what's the like really awesome thing that if we didn't completely factor everything that we can see here? Is there something common between the numerator and the denominator? This whole piece factors out and divides out with each other. Now, this one we do still have to factor. So if you're sitting there going, gosh darn it, why didn't I do this? This is so much easier. We just took out some values that would have made us divide by 0. So we still have to do the work there anyway. If you didn't catch it, it doesn't change anything about it. Let's just keep factoring. So we factored and flipped here, but we're not completely factored. So let's keep going. More factoring to go from here to here. And that should have been pink. That's my bad. More factoring. Now, I hope I stress this frequently. We can take different routes. Everybody thinks about math a little bit differently. I've not been your only math teacher, so naturally we're going to have a little bit different thought processes. But as long as you're not breaking the rules of PEMDAS and order of operations and stuff, it's okay. Interesting. Okay, so looking at this, help me factor this other one. Factors of negative 30 that add up to 1? Plus 6 and negative 5 will do that. Okay, so I'll go ahead and do that x plus 6 and x minus 5. And then this one's going to stay all the same for now. X plus 3 and x minus 6. How about this numerator here? Love it. Angel, you are killing the factoring. Somebody not Angel, when he factored this quickly in his head, he's using a really convenient shortcut. What is this type of factoring to go from this to this called? It's a difference of squares. Every time it will work like this. And let's do the bottom. Do I really have to think this out again? No, if you're like mindful of where we've been, I've already factored it. I know it's exactly x plus 6 and x minus 5 because it's the same thing. Now, whether we simplified it here or not, again, we needed to know what numbers these were. I'm going to try to do it this time without rewriting it as a single fraction because I know they just shoved together. Okay, all I'm looking for is, are there any common factors between the numerator of this thing and the denominator? X minus 5. So I have one here and one here. Now, every time I cross one out, I'm going to make a little note here. And I'm actually going to use a star because it's important. Notice this is not pink. This is something I think you should do. Every time, what value of x did we just make it or just identify that we can't have? So we can't divide by 0, Lando. But that question, what makes this 0? It was x minus 5. 5, right? So x can't be 5. As soon as I cross one out, I'm going to make that comment, which is why we had to factor anyway. Any other values that divide out? X minus 6. This factor that we're dividing out, if we made it 0, what would we get for x? And again, just to stress, it's me doing this in my head, which I think most of you can. What value of x would this have been 0 with? So what can't we have? X cannot be 6 then. I agree. Any other common factors? So I'm going to clean up your language. I know that you know what you mean. The common factor is x plus 6. It's going to divide out, and I'm cool with that. And it doesn't matter if I cross this one or this one. Irrelevant. What value of x would that have needed to be 0 since we just crossed it out? I heard a couple of people say it, but it was all together, so I didn't quite catch it. Negative 6. Are there any other common factors? Are you sure? There's an x. Now, for this one, and if you're zoning out right now, I'm going to say don't, because there's a couple ways you can do this. My notation, I know that this means what? What does x squared actually mean? X times x. The way that I typically do this is I'll just cross out the square, and I'll cross out the x. Now, some of you don't like that, and I'm sure of it. Just to show you the same thing is going to happen. If instead of writing x squared, we had elected to write x times x, which is the same thing, now I imagine it's probably a little bit more clear that that and that cancels. Do I now just have an x to the first power? Like, that's what's here, right? If I want to, and this is my style, I'll just see that happening. I'll say, oh, the square goes to a first power, and it divides out. What value of x just now, or the fact that we divided out was x, and it's always a silly question, what would have made x equal to 0? So what can x not be? Because it makes us divide by 0. X cannot be 0. And look at all these values that we're finding that just don't work. Are there any other common factors here? And if there's not, or if there are, we should cross them out. But if you don't catch it, we're still not quite done because this is awful, right? Like there's no nice presentation of this. Don't you dare give me an answer with this. We're going to go the one last step, and it serves as a really good check to see whether or not we're done. So what's all left in the numerator? There's an x and an x plus 6. And the only thing left in the denominator at this point is x plus 3. And I'm going to do the same thing here. Seabass, give me 1 second. I still have to come back to the same question that we keep asking. I don't want to break my function. Is there a value of x that could be chosen right now that would break it? Why? So good, I agree with you. When I say, will it break it, what am I actually asking? Does it make me divide by 0? Sunny claims negative 3. Why? If I chose x equals negative 3, here I divide by 0. So we'll just go ahead and say x cannot be negative 3. And then here's the fun part. Ron John, do you want to do interval notation? Are you sure? I want you to think about this very carefully. So good. One, I love that comment. I would not draw this. I'm just trying to show Ronald that this won't work. By the way, I'm trying to use a new nickname every day, just so you know. So if there's a name that I shout out that nobody knows, but there's a Ron anywhere in it, it's probably Ronaldo. Cool. So if I put all these on a number line, and hopefully I can convince you of how awful this is. I made 1, 2, 3, 4, 5 cuts, right? If you cut a piece of bread 5 times, how many pieces of bread do you wind up with? So we need either 6 intervals with 6 unions, or a nicer way to write the answer. I don't want to do interval. And I hope none of you guys want to. If you are saying, yeah, I would do it because I know how to do this one, the other one is so much easier. These are the only x values that don't work, right? Does every other x value work? So if we wanted the domain of this, and I'm going to call this f of x just so we have something to talk about, and I should have done that up above, I'm sorry. But if we wanted to talk about this domain of the function f of x, this thing that we just worked with, I'm just simply going to say it's the set, curly bracket, of all x such that what can x not be? It can't be any of those values that we just identified. Would you like to see the interval? Okay, so the fact that somebody said yes, no idea who it is, I'm going to use a little editing magic here. If we do the interval, both of these answers are equally correct. Both of these answers are equally valid. Only one of these answers made my forearm tired while I was writing it. It was definitely not the first one. Okay, for today, I have a really awesome word problem that I would love us to work through. But I'm going to be honest, it's pretty far out there. Here's the deal. If you would like the opportunity to earn a late homework pass, it means that I won't give you a late penalty when you hand in late homework. I have a problem for you that I will assign. I'll make an asterisk problem for the homework tonight. Remember, though, as we're doing these, if you do it and you bring it in, I might ask you to explain it to me. So if you just copy your friend's work, you have no idea what's going on, you probably won't get the homework pass. Cool. So for now, we have a little bit of time to work on an assignment. I'm going to put it on Google Classroom so that I don't forget to do so. And let's see how it goes. So we're in first hour algebra. Eventually we'll be in first hour algebra. There we are. All right, today is the 29th. Why didn't I put anything there yesterday? Weird. Did we just work the homework examples yesterday? Did we just work through several problems yesterday?
Yep. We did one problem.
We did like one problem pretty much.
What did we do with the other 50 minutes? Huh. All right. Anyway, tonight you guys get the privilege of working homework 4.3. I'm going to bold it. Homework 4.3. You guys will find waiting on page 202. And I want you to do 11, 12, 17, 20, 23, 27, and we'll say through 30. And I got to find out, because I was going to do this big word problem as the whole class, but I don't know that it's necessary. So I'll tell you, I just don't think it's necessary. Okay, there's an asterisk problem, which this asterisk means what? This is the challenge problem. Now, just because I say that, don't think that it's going to be like crazy challenging, but this one's going to be weird. The try it problem. You'll see it as try it number 6 on page 201. So, we have these problems. Tomorrow is Friday. Baller. Cool. Tomorrow, I think we're going to finish the chapter, is what I think is going to happen. Tomorrow is also the last day for anybody who wants to improve their quiz grade to do that, because I don't normally allow quiz retakes. So, I want you guys to get started with this. If you want to retake the quiz, let me know. Lunch, right after school, tomorrow before school, or tomorrow at lunch are your options. Okay. Okay, come remind me after school, because I don't do study hall today. All right. Cool. 5 minutes, you'll be able to get the first few problems done. Sweet. If you do this, try it number 6. Last little comment I'm going to make. If you elect to do this for a free homework pass, I need you to do the rest of the assignment also. You can't do just this problem to use it as a late homework pass for this assignment. Cool. Loophole, close. Baller. All right, do it to it.